That is what I did kind of a lesson yesterday, and I will upload it also in the Google Classroom so that you can just,
Okay.
it's not really complicated, because what I was emphasizing is, we were doing factorization. So whenever you're looking at fractions, now fractions is an extension of factorizing. So that is the main thing. The only difference now is that you are dealing with fractions, but the concept there is the concept of factorizing, coming from the first one, which is the difference of two squares, the second one, which is factorizing by grouping, and the third one, which is using the product sum. So once you master those ones, you will then be able to do your fractions without a problem. Okay.
Okay.
But let's just look at an example for this one. It says simplify the following. This is one question from a previous paper. So you are required to simplify. Now you need to identify each and every item that you're given. For example, if we look at x squared minus 9, if I can write it on the other side here to say what I have there as x squared minus 9 is back to those difference of two squares, which is x squared minus 3 squared. Remember, the 9 there is the 3 squared. So you can see that difference as the negative sign. So that is the main part that it requires you to identify there, so that you have your x minus 3 and you have your x plus 3. So what I'm trying to emphasize again is you need to always revise your factorization in detail, because once you master those concepts, when you come to these fractions, it's just a matter of recalling and working it from a fraction perspective,
Okay.
So now for this one, that's what we're gonna have here as x minus 3 and the x plus 3. But you need to show your working always. So this is the one. Now let us look at the one at the bottom. Now I'm looking at that one to say if you are given 4x squared minus 9. Now I'm just going to do it in two ways, because already I see there is something similar there, and there's also something similar here and here. But now let me do it the long way so that we can go through the concept of factorizing. So now when we are factorizing again here, you look at 4 is a square. You remember 4 is 2 squared, and then you've got x squared, and again 9 is a square, which is 3 to the power of 2. Now when you solve it, this is again your difference of two squares. As I say as a reminder to students, is you must express everything in square, and then you pretend you don't have those two. Like
Confident?
Yes, ma'am.
Sorry, I see the speakers on you. Just 1 second. Sorry.
Yes, ma'am. No problem.
Sorry about that.
No problem, Zanda.
Okay.
Are you cool? You good?
Yes, I'm good. Sorry, man.
Okay, but can you hear me clearly?
I can hear you clearly.
Okay, so what I was saying is, whenever you are dealing with the difference of two squares, I always remind students to say, first of all, you must express everything as a square. You need to express that 4 as a square and the 9 as a square. And when you have done that, to write now your difference of two squares format, just pretend you don't have those squares like that. Just pretend you don't have that. And what you see is what? Is 2x minus 3. So that is what you'll be writing in the bracket. Initially, that is what goes in the first bracket there. So that's what actually you pretend you are having. So you have your 2x minus 3, and the other one is simple 2x. Then it's the opposite, which is plus 3. Okay, so that is what you will be having over on this other side, which is 2x. It's 2x.
2x minus 3.
Yes.
2x plus
3. 2x plus 3. Then if I'm to factorize, I'll just have to, that's why I was writing it on the other side, so that I can just use the same space here. Now the next one that I want to factorize, it is this one here, which is the numerator here, which is 8x plus 12. Now it doesn't have any powers, it doesn't have any x squared and stuff. So this one is basic, whereby you just have to focus on the number, what is common between 8 and 12, which is the number 4, because the highest common factor of 8 and 12 is 4. 4 can go into 8 2 times, which is 2x, and then into 12 is 3. So you'll have 2x plus 3. Remember, every time you do it, don't forget to try quickly to expand it to see that it gives you back that one, okay? Because that is how you always keep on checking that you are in the right track. So when you do that, you will have divided by, then you have 4 into 2x plus 3, alright? And then this other one is similar to that one, so I'll still write the 2x minus 3 and the 2x plus 3
Plus.
and then it says times, again this is similar to that one, which is our
Alright.
4 into 2x plus 3, and then over. Now when we factorize this
That's
4x minus 12, similar also, what is common between 4 and 12 is 4, which will become x minus 3, okay? So you can write that there as 4x minus 3. So now when you have done that, that is the part. So remember, you don't have to, I'm erasing this working part, but you need to show the working. Don't just show this scenario here. They will penalize your marks now because you are not showing us the intermediate steps. You are just coming up with answers, and the question is, how did you get these brackets? So you need to be showing the working, which was this side. It is very important, okay? So that is important for you to show, please remember. Now, when we've done that, we come back to this part. Now, you cannot do anything as long as you have a division sign still existing. You must convert it into a multiplication sign. That's the first thing. So you're going to convert that from division to multiplication. It's very important before you can do any kind of cancelling. You can cancel within the bracket, but I advise first deal with that sign first. If you do that, it won't do some confusion on your side. Then when you do that, so we have here our x minus 3, and I have my x plus 3 over 2x minus 3 and the 2x plus 3. Now from here, remember, I've now changed from division to a multiplication sign. Also, my fraction, what was at the bottom goes to the top, what was at the top goes to the bottom, because of that change of sign. So it means now the one that is on top now is 2x minus 3 and it's 2x plus 3. This follows after changing from division to multiplication. Now at the bottom I have my 4, 2x plus 3, and then I multiply by that. There is no change in sign, so nothing changes there. So it's 2x plus 3 over 4x minus 3. So when we've done that, since everything is multiplying and multiplying, then you can do your cancelling without any much challenge there. You cancel what is common. You have got your 2x minus 3 with your 2x minus 3, your 2x plus 3 with your 2x plus 3, and our 2x plus 3 with that other 2x plus 3. I have got the 4 here, which goes with that 4, and I've got the x minus 3 here, which goes with that x minus 3. So remember, when you're cancelling, you're just writing 1, 1, 1, 1, 1, 1, 1, 1, 1. It's like 1 is remaining. So when you write your final answer there, so that if there is nothing at all, you'll know that it is actually 1 that is remaining. So if you look at the first one, it's 1 times that, which is x plus 3 in brackets there. And we look at the top, we're looking at that, which is a 1. Now we wrote that, and this is a 1, this is a 1, that is a 1, that is a 1. So that's all that is at the top, which is our numerator in this case. So it is x plus 3 all over. We look at the denominator. We have a 1, we have a 4, and that's all that we have, like that. So the answer is just like that. Okay. Now the question then comes is, how do you know, Zenda, that you did the right thing? Sometimes you need that kind of assurance to say, what if I made an error? How can I test my answer? So what I advise students is, you can test this answer like, let's just look at, if I can use a different pen to say, you can test it. Now what do? You choose any number. For example, you say, let our x, just choose any number for me.
4.
4. So you say, let x be equal to 4. So what you're going to do is, you will take your calculator and you come back to your original question. I'm talking about this one. Let me just erase. This is your original, where you started from. So you come back to it. Now with the calculator, what you do is, wherever you have x, now you're going to input the value. You say 4. So for example, the first one is 4 squared, you see, minus 9 over 4 into, or 4 times 4 squared. Remember, there is minus 9, so don't get that confused when you are entering it. It's 4 and then x squared. Sometimes you can put a bracket here to protect this other 4 that you are substituting, so you can do that. It's much better. That's the proper way. And then you have your divided by. You do the same thing, which is 8 times 4 plus 12 over 4 squared minus 9, and then we are multiplying by 8. It's a fraction again, which is 8 times 4 it's plus 12
over 4 times 4 minus 12.
Now when you've done that, under equal, so you see I'm getting 49 over 55. So here I'm getting 49 over 55. What I'll do, I do the same thing on this x plus 3 over 4, and I need to get a similar answer from that one. So on this x plus 3 over 4, my final answer here, I will have, remember we said it's 4 plus 3 all over 4. So I'm supposed to get a 49 over 55. So you see the answers are different. When the answers are different, it means somehow, somewhere, there is an error that we did. So we need to go back now. That's where you check now to say, what is it that I might have done wrong? Because you saw that the answer did not come out as it was supposed to come. So what you do the same, check again. The first one, x minus 3, x plus 3, it was fine. 2x minus 3, this was fine. 2x minus 3, 2x plus 3, that was fine. We divided, and when we divided, we took out the 4 on the first one, which was 2x plus 3, it was fine. And 2x minus 3, 2x plus 3, that is fine. We multiply, and then we took out a 4, 2x plus 3 over 4x minus 3. So this so far is fine, and we used our interchanging, whereby that one went on top as we did on the second one. I'm here now. And then the other one went below, and now that was fine. And now when we're cancelling, let's check what, in case maybe we forgot something on the cancelling, is x minus 3, x plus 3. That one is the one that remained here. And is there anything that remained on top? We cancelled anything. But now let's check again, just to put our calculator back in. Maybe there was an error. We said x was 4. So let's try it again, just to make sure we didn't make an error. So it's 4 squared minus 9, and then 4 and 4 squared minus 9. Am I right?
Yeah.
Divided by, and then you have got your 8, then we've got our 4, plus 12, and then we've got our 4 squared minus 9, and then we've got times, we've got 8 there, and then we've got our 4 plus 12. Am I right?
Yes.
We've got our 4 minus 12. I think that was that. I think I made an error. You see now the answer is changing now. So
Yeah.
the answer here is supposed to be what? 7 over 4. So let me control check that. It's 7 over 4. I don't know where I made an error there. So let's come back to this other one and check again. We've got our 4 plus 3 all over 4, and we're getting our 7 over 4. You see that now it's making sense. So why am I doing that, Zenda, with you? I'm doing it so that you are also in that exam room. You want to be sure I didn't make an error here, and you don't want to be overconfident to say I know this thing came out right. So that testing, in as much as I see that nothing was wrong, but for you to be conscious that you can make an error is actually even better than to just leave it, maybe only to discover that you just made a slight error when you were cancelling down there. So everything was fine, but you just made a slight error changing out your everything. So it's always good for you to have those kind of tests. But remember, this testing is not supposed to be in your, it's something that you're doing it outside, This you must ensure.
Yes.
This you just do it in your work, just for you,
Yeah.
Are you with me, Zenda?
I'm with you.
Okay, so now that was the multiplication, as I say. Sorry, man.
That's a lot of more.
Yes, you find, sometimes they are actually stingy. They can give you 3 marks, sometimes 5 marks, I'm telling you. Sometimes coming up with 5 marks or 6 marks, but sometimes they can be stingy. Another thing that I wanted to show you on this one, there was a quicker way, a very, very easier and quick way. What you have to do is to identify these things that are equal, similar, like this. Do you see that it is similar to that? So you could have actually went straight and say this was x minus 3 here, and x plus 3, alright, over, you leave it as it is, x squared minus 9, and then you do your multiplication. Remember, it goes to the top and this goes to the bottom. So when it goes to the top, it's 4x squared minus 9 over that 8. We said it was 4x plus 3. That one we change. Actually, no, let's not change it. You know why? Because we have it also here, that and that. You see that? So I'll leave it as 8x plus 12, and then times 8x plus 12 over, we can change this one because it's not repeating, which is 4 over x minus 3. So now you were allowed now to say the whole of this cancels, it's similar, and 8x plus 12 cancels 8x plus 12. You see that?
Yes.
So that was that. And then what else are we having? We have x minus 3 cancelling x minus 3, yes. So you see now the final answer into this then was going to be on top, you've got that, which is x plus 3. At the bottom, you just got that 4 over 4, which is similar to what we just did there. You understand what's happening there?
I'm understanding you, man.
Yeah, more or less it was going to work out the same. Now, as I said, Zanda, I'm going to upload, the video is already done. You can rely on those other lessons, plus the one that I did yesterday is more relevant, just on that multiplication, where the main lesson, you will see later, the main lesson here is not actually the multiplication, Zanda. The main lesson here is for you to remember factorizing. That's all that they're trying to test here. So in the final exam, this question is question number 2. After they ask you that one for lowest common multiple, highest common factor, and factorization, they bring these fractions because you are still using the same concept, but now it's just a matter of reminding yourself, if it's a division, what do I do? And if it's a multiplication, I just leave it like that. That's all that they're trying to test there.
Okay.
Alright, so it's just an extension of factorizing. Think of it like that. Now let us look on to this one, today's lesson. In this one, I want us to look now at addition and subtraction of fractions. It is the one that I would think it carries even more work than what we're doing in multiplication, because you see, multiplication, as I told you, is just factorizing, but with addition and subtraction, it's in a way kind of a different concept altogether. So now you are given that. Let me just give an example. For example, if they say to you 1 over 2 plus, I'm just using an example here, 2 over 3 minus 3 over 2. Let's say they just give you that and they say you need to add. So if I can use my calculator here, just want to show you something. It will be 1 over 2 plus, and then I have 2 over 3, and then I have minus 3 over 2. So it's 3 over 2. So now if I've got that, see, my answer is negative 1 over 3. So now if I've got this as minus 1 over 3. Now the question is, let me try to work it out without the use of a calculator now. There are many different ways of doing it, but I'm just going to go straight to the one that I always prefer. What I usually do is I look at the denominators. Remember, this is the denominators, the ones that are below, and then I take them as they are. I've got a 2, I've got a 3. If the other one is repeating, I can leave it out if I want, but for interest sake, let me just write it again. But you're supposed to leave it out because it was repeating, but let's just add it because it changes nothing. Then after that, Sanda, what I'm doing is I'm going to start with my first one, which is my half here. So when I'm starting with that one, what I'm doing is I'm saying that 2, that 3, and that 2, remember the common denominator, I'm dividing it over the 2, that will be the first one. Then after that, I will change it to 3 and stuff like that. So when I start with the first one for 2, that will cancel. Do you see what is remaining there? It's 3 and 2. So that is what is going to be happening. So here I'll write here 3 in brackets, that was remaining, and 2 was remaining, and then I multiply by that top, which is bracket 1. Let's repeat again the second one. I do the same thing. Now instead of 2, I'm going to the next one, which is my 3. So I put the 3 here. So when I cancel the 3, that and that will cancel, remaining with the 2 and 2. Do you see that? So with that, I'm going to have my 2 and my 2 multiplying the top, which is my what? Which is my 2. Okay, then minus, I do the same thing, take out the 2 again here, and this 2 will cancel that. So when it does that, I'll be remaining with a 2 and a 3, and on top I've got a what? I've got a 3, which is multiplying also. So that's what actually is happening. Now with that, you can simplify it now further to say 3 times 2 times 1, which is 6, plus 2 times 2 is 4, 4 times 2 is 8, minus 2 times 3, which is 6, 6 times 3, which is 18, all over 2 times 3, which is 6, 6 times 2, which is 12. You know, so now what you're having is 6 plus 4, which is, I think it's 14 minus 18 over 12. Now if you say 14 minus 18 is negative 4 over 12. Now if you just quickly check with your calculator what is negative 4 over 12, so it will be negative 4 over 12. You can see that is giving me negative 1 over 3. So which is the answer, remember, that we got? Are you seeing that? So I used this example. It is important when I come back now to my question here. I'm now here to say I got this question now in terms of x. So what I do is, for me to solve it, I look at my denominators, I write them as they are. I've got my x in brackets, I've got my 3 in brackets, I've got my 2. Then That's what I do identically to what I was doing here. So in the first one, I'll have my x, as I said, my 3 and my 2. So I'm dividing the first one by x. So what will remain when I cancel out the x? Only 3 and 2 will remain. You see that? So now I will write in brackets the 3, the 2, but I also have the top there, the numerator, which is going to come also and multiply there. Right? Then I repeat again. The next time it's no longer x, it's now my 3 here. So when I've got the 3, what will remain? It will be the x and the what? And the 2. Are you with me, Zenda?
Yes.
And then on top there, the 2x is the one that is still remaining. Again, I change. Now instead of 3, I've got my 2 now. So what will be remaining is x, which is negative there. Now it's negative x. And because 2 is gone, it's 3. And on top there, it is 3x. Okay, so that is basically what I'm repeating, the one that I was showing you with the numbers. So if it was working with the numbers, it means it will also work with the x, you know. So now after that, I multiply 3 times 2, which is 6, 6 times 2, which is 12. But I'll encourage you to use a calculator because for multiplication, don't make an error, you know, a simple error here to say 3 times 2. Sometimes, I confuse it. Sometimes I'll say 3 times 2, find that I wrote 9. You know, the pressure of the exam can actually make you make errors. So always rely on your calculator to do that.
Okay.
So 3 times 2 is 6, 6 times 2 is 12, plus then x times 2, which is 2x, 2 times 2, there is, I think it's 4x squared. I think it's 4x squared there. Then after that, I've got 3 times 3, which is 9x squared. Am I right?
Yes.
All over. Now you can multiply the bottom now, which is 3 times 2, which is 6x. Okay, so that's what you'll be having. Then after that, you continue and say, how does this simplify? The like terms, they'll subtract, of course. So here we have got 4 minus 9. It giving you, I think it's 4 minus 9. It gives me a negative 5. Why am I saying that? Because this is x squared and this is x squared. These are common terms, so I can subtract 4 minus 9. Are you with me?
Yes.
So it's 12 minus 5x squared all over 6x. So now there is nothing common anymore. There's just 12 as a number. We've got 5x squared, something different. We've got 6x, something different from the other two. So this is final. We can't go any further than that. Okay. Now the question is, I told you, how do you quickly verify? You choose any number. What do you want us to try? Maybe x is equal to 2. So what you do, you quickly go to your original and say, here it's 2 over 2 plus, you do the same thing, 2 into 2 over 3 minus
3 times 2
3 times 2
over 2.
over 2. So you're having that. The answer is negative 2 over 3. You do the same thing at the bottom.
Alright.
You see, it looks totally funny at the bottom, but when it matches, you know, you feel like, okay, at least I know even it did actually work out to become the same. When you do this, it's negative 2 over 3, which is here also negative 2 over 3. You know, you don't have to be using your feelings to say, you know what, the answer came out funny, I don't think I just got it right. You can actually test it yourself and see if it matches like this, chances are very high this is correct.
Confident, I like this. I like this a lot. Very nice.
You understand what is happening?
I understand it. Yes, this works. This will work brilliantly.
Yes, you will see actually, Zenda, that almost 60% of your paper, if not 70%, you're going to be checking it yourself. So if you can master this way of, after doing it, can I quickly check it? After doing it, so you now know in factorizing, you can do the same. You choose any number, you test your original with your final, In your fractions, you do the same thing, test with your original with your final. As long as you keep matching, you have got a high probability that your answers were correct all across.
I like it, my man. It's very nice.
Cool, man.
Are you gonna put this? Are you gonna put this lesson in also? For,
yes, I will upload. You know, while I'm doing this, the lessons are also being recorded. You know, so after this, what I do is, it's just that I'm the one who has delayed uploading. But during the weekend, what I do is you'll find things that are being uploaded in your Google Classroom, so that it will be those lessons that we're doing in the previous classes.
Okay, thank you.
So there is only one lesson that we started with. That one, unfortunately, I did miss to upload, but everything we're doing is going to be uploaded.
Okay, cool.
Okay.
Cool.
Now let's move on to this other one. It's still addition and subtraction. So in this one, it says simplify the following, as you can see. Now it looks like it's a fraction because it's 3 minus a over 3a. The other side is a fraction, but this one is just like a 1. You know, I think I got this from a previous paper. It was 3 marks, this question. So now the question is, how do you go about this? The simple thing is convert this one into a fraction. When you convert it into a fraction, if it's a 1, you've got many ways of doing it. You can actually say, I want it to be 3a over 3a. You know why I got it? Because I'm using this 3a. Because 3a divided by 3a is a 1, you know. So I can do that if I want. But just for argument's sake, let me just use what I usually do. I say 1 over 1, because 1 over 1 is simple a 1. So you've got now your fraction like that. And then how do you go about simplifying it? You do the same thing like what I did. Take out what you have at the bottom, so that you've got your denominator here is a 1 and your denominator here is 3. So you take out your 1 in bracket, you take out your 3a in brackets. Remember I said you take them as they are. So how do you go about? You do what we're doing in the previous one, to say I've got my 1 and my 3a. The first one is that 1 that I'm dividing, so it's over 1. I mean, 1 does not change anything, so when it cancels like that, I'll be left with what? With that 3a. You see that?
3a.
So it will be 3a here, and then minus. Now this time I'm dividing by 3a, which will cancel to remain with a 1. So it's minus 1 times 1 times, remember the bracket, which is 3 minus a. I was supposed actually to multiply even the top by a 1 there, which I forgot, but you see 1 does not change anything. I mean 3a times 1 will remain as 3a. So when you've done that, you continue to say 1 times 3a, as I said, it will remain as 3a. Now the only thing that is now important here, they wanted to check, Xander, is this particular negative. That is where they are checking, because this negative, you must distribute it inside and you must distribute it inside. So what is important here, let me emphasize this again. When I said you are cancelling and you got a negative 1, it is very important for you, don't just say negative 1 and you say 3 minus a. If you do that without putting that bracket, it means the negative will only affect the 3 and not the a, so automatically your answer becomes wrong. So that negative must affect the 3 and the negative must affect the negative a, because you must distribute it or expand inside. So it means then you will have minus 3. Now negative 1 times a, it's a positive a. So that is what I think they were trying to check, if ever you are sensitive of that negative there. And then 1 times 3a there is simple at 3a. So when you do that, continue, you collect your like terms, that and that is common, which is 3a plus, a is same as 1a minus 3 all over 3a, and then you continue 3 plus 1, which is your 4a there, minus 3 over 3a. You know, that is the end. That's how this was supposed to go out as. And then quickly you can check, we choose any value that we want for a. Maybe we want it to be 10, so you say 1 minus, I'll choose 10, so say 3 minus 10 as my A over 3 times 10. Are you seeing that? Then my answer is 37 over 30. So here I'm getting 37 over 30. So I do the same thing on the bottom of the final one, which is 4 times 10 minus 3 all over 3 times 10. And I'm getting 37 over 30. So you see how this thing keeps on working out to say, when you do this, you'll know that, okay, I can actually go out knowing, okay, more or less, I didn't get that thing wrong, you know. So that's how we go about it. Okay. Now let us look at this one now, just to kind of wrap it up. Now let me not do this one, Zenda. I've got another one here. I want us actually to do this one, but can you please write this one down quickly? I want you to try it on your own. For tomorrow, you just give me a quick feedback. Quickly write this one. Say simplify 3x over x minus 3 minus 2x over x squared minus 6x plus 9. If you can quickly write it down, then I'm going to do the other one similar, and you will use the same concept to solve it. Okay, so now try that one. Then let me do this one. Let's do this one together. So what we have here is still fractions, and let me give you a hint already. If I'm working out, you know, these guys who are giving out this question, they are already knowing the final outcome, so they don't just give things randomly. They will give you something that is related. For example, I can bet you that this x minus 2 and x minus 3 is not just something coincidental that they just put. It has got to do with something related to that. So whenever you're working on these things, you must also work with that in mind to say, somehow, the way they are giving these questions is not just at random. They don't just pick out any numbers. They work it out, and then after that, they bring it back again to say, we know what we want the student to achieve out of this. Okay. So let's start with this first one here, x squared. That's the one that actually needs some work, because you cannot don't do this now on this one to say, you do that, I say you take out the denominators, and then you say x squared here minus 5x plus 6. Now here you've got your x minus 2, here you've got your x minus 3, and then you start ruling off. You're not going to get it right. As I said, they don't do things randomly. The first thing you need to do is to factorize this guy. You need to factor. Okay, that's very important. You need to factorize that. So when you are factorizing that, it will be, I've got x squared minus 5x plus 6. Now remember, product sum, there is a 1 there. What I do, I take the first one and the last one. What I do is I multiply to give me my product, which is positive 6x squared, because it's 1 times 6, which is 6x squared there. And my sum is the center, which is negative 5x. And my factors are the factors of the product, which are the factors of 6. Now what are the factors, or the two numbers that I multiply to get a 6? It's 1 times 6 and it's 2 times 3. And the other one is 3 times 2, which is same as 2 times 3. So these are two ways of getting a 6, but the decider, remember, is always your sum. From these two numbers, I must add the two numbers to give me a negative 5. So now the product is positive. If the product is positive, it's either both numbers must be positive or both numbers must be negative. Negative 2 times negative 3. Why? Because the product there is positive. That's why when you multiply and say negative 6 times negative 6, you will get negative 1 times negative 6, I get a positive 6. You see that? So that's why it's either both numbers are negative or both numbers are positive. But now, as I said, this is our decider, which is the sum. So when we add these two numbers, let's add them. The first one is 1 plus 6. It's not giving me a negative 5. The second one is 2 plus 3. It can't give me that. We use the next one, minus 1 plus minus 6, again it's giving me a negative 7, and minus 2 plus minus 3, it's giving me a negative 5. That's what I want. So which means these are all out except these two numbers, which when I write them properly, it's minus 2, because it's in terms of x, it will be minus 2x and minus 3x. You remember that? So when I factorize, I'm just going to erase because of space. So when I factorize this Zenda, as I said, you see that they are taking you back again to factorizing, because it means our lesson on factorization must be very strong going forward, so that whatever problem they bring concerning factorization is not the one that is actually limiting you. So what we do, we take our x squared, and then we take our factors here to be minus 2x minus 3x, and then I have our plus 6. Then we do that grouping, your first two and your last two. So my first two is x squared minus 2x. I'll take out the x, which is x into x squared is x into negative 2, it's negative 2. I do the same now. I start with a plus, I know it's a negative there, but 3 and 6, I take out the 3, which is 3 into minus 3x is negative 3. I mean it's negative x, sorry about that, because I've cancelled the 3, so the x will remain but with the negative sign, and then 3 into 6 is a positive 2. So I interchange now. Remember, I've got a negative x plus 2 and an x minus 2. It's only the issue of signs there, which will be x minus 2. Then I've got minus 3. I've taken out a negative. It was positive, now it's negative. Then I'll have a positive x. Where it was a positive 2, I'll have a negative 2. Then my answer there, these brackets are now matching. It is x minus 2, and outside it's x minus 3. Are we together, Zenda? Now, with that, hence I say to you, they don't give something at random. Look at the brackets, we have that and we have that. You see what I was meaning? So whenever they give you something, they give you knowing what they want to achieve. So you have to continue then with this one and say this is x over x minus 2, x minus 3, plus 1 over x minus 2, and then it's plus 3 over x minus 3. You know? So now, in this case, when you have done that, what is our common denominator? Our common denominator, since this is that and this is that, so our simple denominator there is x minus 2 and x minus 3.
Yeah.
You understand?
Okay.
So that is our common denominator there. And repeating again, as I said, what you are doing when you are taking out that common denominator, just to quickly show you that, because it also needs to be careful now what you do with the multiplication. So let's start with the first one. The first one, remember, it is that x minus 2, x minus 3. So I'm going to take it, our denominator is x minus 2 and our denominator is x minus 3. That is this one. And it is divided by x, identically similar, x minus 2 and x minus 3, which is that part. I see that. So that cancels, I get a 1. So don't forget that it cancels out everything so that I get a 1. So what I write there, I'll write 1 times the top is what? Is the x. Don't forget that top. And then I move on to plus to the second one now. In the second one, I erase to write the denominator there as x minus 2 only, so it will cancel that, which means x minus 3 will remain there. So x minus 3 is remaining. I have x minus 3, but don't forget it's multiplied by that top, but that top is simple a 1 there. I move on to the next one, plus. In this case, I remove that. It's now x minus 3 here. and then that goes to remain with x minus 2. So you will have x minus 2, but don't forget that must multiply. So you have a choice. It's wise for you to put the 3 not here, but put the 3 in front, because it will be easier for you to expand it. Do you understand? So put it in front than after, because it's easier for you to do this and to do this. Unlike when you write it after sometimes you find that you write it here, so you have to do this now. It confuses you because you're not used to that, okay? You're used to multiplying it going forward, not backwards. So it's better to always start with a number in front of the bracket. Please don't forget the brackets are important, because if you leave out the brackets, you won't distribute it like that. You will actually end up saying 3x instead of 3x minus 6.
Oh, yes.
So you see, this will multiply to give us a 3x, and the 3 will multiply to give us a negative 6. But if you forget the bracket, what you're going to have, you're just going to have something like this.
3x minus 3.
Yes, you get it. So you're going to have your 3 here, it will be 3x minus 2. So you see that you have lost the whole, you have just made an error. That negative 2 was supposed to be also impacted by that 6, by that 3, okay? So that is very important. So now let's expand. 1 times x is our x, and plus x, this is 1 times x minus 3 is minus, nothing changes there. And then we, as I said, we open that bracket to give us 3x minus 6. Always, please don't forget, you always have to maintain your denominator. Don't leave it out, because they will penalize your mark if you just let it go. It always goes with you. X minus 2, x minus 3. Then after that, you can now take out common terms, which is 1x and 1x and 3x there. 1x plus 1x plus 3x. Then I've got minus 3 minus 6 there. Common denominator stays as is, x minus 2 and x minus 3. Then after that, still continue, use your calculator. 1 plus 1 plus 3, which is 5x minus 6 over x minus 2 and x minus 3. As I said, quickly.
Is it minus 6, or is it not minus, because a minus and the minus makes it a positive? No. Isn't it 9 minus 9?
Come again?
Isn't minus 3 and minus 6 give you minus 9?
Yes. Thank you, Zenda. Thank you. It's minus 9, you're right, actually. It's because it's minus 3 minus 6, right? Yes, it's a negative 9. Thank you for that. You're right. So that's, you see, even if it was me, I've made an error there. That's why I keep on saying I rely on testing these answers, because if I just rely on me doing the right thing, in the pressure of the exam and everything, you're bound to make a slight error. And just think of it, I was doing everything right, but in the final answer I just make an error like that. It makes you angry,
Yes.
It makes it. So let's choose any value of x that you think we can choose, just to test it quickly.
3.
3. So we have 3. Okay, now look at this now.
Yeah.
I'll tell you the reason why. Okay, I'm gonna use a 3 so that you can see what will happen. But when you get that answer, still continue, choose another one. Let me quickly do the 3 so that you see why I'm saying it. That's a good one.
Okay.
I like that you chose a 3 there. So it will be 3 squared minus 5 times 3, then plus 6, and then plus 1 over 3 minus 2, and then plus 3 over
3 minus
now
3.
That is the one that will cause this calculator to say error, because any denominator which is a 0 at the bottom, remember 3 minus 3 is a 0, when you say equal to, you see, it will give an error. But don't worry, come back and change now to say, instead of 3, choose another number. 2. So you do 2. Again, 2, it will be 2 minus 2, so it won't work. You see that?
Okay, let's take 10.
10. Okay,
Solid
let's
10.
take 10. But you understand what's happening. So if it gives you an error, don't come back and say, no, it didn't work out, now it was giving me errors. It's nothing wrong to get an error, because you can just choose any other number, You can choose 15, you can choose, just keep on trying other numbers until you can get an answer on it. So we've got 10 there.
Okay.
So you got 10 there. So now it's giving me 41 over 56. You see this one? Let's try to remember it. 41 over 56, because I'm going to enter now this other one. So we've got 5 times, sorry about that. It's 5 times 10 minus 9. Remember that other one was 41 over 56. So
yeah, 41 over 56. I wrote it down.
Yes, 10 minus 2, and then 10 minus 3, and there we go, 41 over 56. So it means we're in the right track. It means we're in the right track. Are you seeing that as a no?
It means you're winning there.
Yes, man. It has to, with the maths, it must be predictable. You must come out with a prediction, it mustn't be like I'm hoping, because mathematics, I feel like it can be proven. Of course, some of them are difficult in a way to try to prove them. It becomes more complicated, but these other ones, we are using any number to just test it. I think it's kind of more basic, so that you can...
With the stuff we done before, and like our first lesson with this lesson, it's not even far, it's like 3 or 4 lessons. I mean, you can already almost get 40%, almost far.
True, man. That's very true. Actually, if we look at that question, Xander, you have actually passed the exam, man. You're very right. You're very right. Yes, man. Xander, I have to comment, because...
I think the other thing that is, where you can make some marks is the graph. Because the graph, if you just understand it, I don't understand it always, but if you understand the graph,
yes,
that's also fast.
Yes, it's true. As long as the basic is intact, when you manage to get that foundation to say they can change whatever they can bring, but if I know how to approach that approach, which is the base, anything, you can still do. That's why get that other activity, that example that I gave you, try it. Test it yourself. You don't even have to ask me to say, did I do it right? You can actually tell yourself, says, you know what, I know I did it right because I tested first one and my final answer, everything came out fine. So I think I'm fine with that.
Alright.
Okay.
Thank you so much, Con.
Thanks, man. I have to now. It's a Friday. It's a Thursday today.
I always have to go somewhere.
Yes. It's a Friday tomorrow. So our classes, remember, is Monday till Thursday. But tomorrow I'll be uploading all these videos so that you can also catch up on the multiplication that we're talking about, so that you can actually be in tune. And next week I will touch a few things. We'll look at previous papers there, so that we can also do some other modules that need to follow after that.
Okay.
Thank
you so much. Must have a nice day, man.
Thank you, man. Enjoy the rest of your day. Cheers.
Thank you.
Thank
Bye.
you. Bye-bye.